So here we continue with the future value for compound interest. In this scenario, we're going to be determining the time. Now keep in mind that you're not necessarily going to get a heading that's going to tell you what variable to solve for. You have to be able to glean it out of the scenario as you read it. So as we read it here, it says, Molly decides to save enough money to put a down payment on a new condo after she graduates college. How long will it take a $5,000 deposit earning 5.25% interest compounded daily to grow to $8,200 needed for a down payment? So again, we have our future value. That's equal to P times 1 plus R over N. That's our rate over the pay periods. Raise that to the N times T power. So as we read through here, Molly decides to save enough money to put a down payment on a new condo after she graduates college. How long? So we know that we're going to be looking for the time. That's T. How long will it take a $5,000 deposit? That's the initial amount. So that's P. That's 5,000. Earning 5.25% interest compounded daily. So we have an interest of 5.25% compounded daily. So the number of pay periods, that's 365. That's a lot. To grow to $8,200. So here's our initial amount and here's our ending amount. So that's our future value. And that's our $8,200. So we'll take our future value, our $8,200. That's going to be equal to our principal, $5,000. 1 plus the rate, 0.0525, divided by the pay periods, 365. How often will this affect our principal throughout the year? Well, that's 365 times throughout the year. What's the length of the loan? Well, that's what we're trying to find, T. How long must she have it into an account? So maybe the first thing we'll do is we'll go ahead and we'll figure out what this is right here. We'll just type it into our calculator as you see it. 1 plus 0.0525 divided by 365. So we now have $8,200. That's equal to 5,000 times 1.00014384. And then that's raised to the 365T power. Now again, this is what we're looking to solve for. So since we have an unknown exponent here, we're going to be using logarithms. So the first thing we want to do is we want to be able to isolate this. So we'll divide both sides by 5,000. That'll cancel and that will cancel. 8,200 divided by our 5,000. 1.64. So 1.64 is going to be equal to 1.00014384 raised to the 365 T power. So now I'm going to take the logarithm both sides because I need to deal with that unknown exponent up there. So I'll take the log of this side. That's going to be equal to the log of this side. And what the power property of logarithms says is that we can now rewrite this side as 365t times the log of 1.00014384. Of course, that's equal to the log of 1.64. Using algebra again, I'm going to divide both sides by 365 times the log of 1.00014384, and I'll do it on this side too. So the 365 will cancel, and of course the logarithm will cancel, leaving us with t. So t is going to be approximately, now we're going to type this into our calculator, except we have to be very careful. We want to make sure that we could delineate between the top part, the numerator here, and the bottom part, our denominator. So I'm just going to type this in log of 1.64. Here is my log key. Log 1.64. I'm going to close off that parenthesis for the logarithm. Divided. Now I'm going to enter this parenthesis down here. So I'm going to put in a parenthesis. 365 times the log of 1.000143. Do you see it building there? 84. I'm going to close off the log, and then I'm going to close off the denominator with this parenthesis here. And then hit enter. So it's approximately 9.42317,605. So the time is around 9.42 years. 0.42 of a year, that's around 5 months. So it's 9 years and 5 months. However, keep in mind that since this is a daily compound, compounds pay or earn at the conclusion of a pay period. 0.42 years, that's around 5.11 months or something. So we're never really going to be, or Molly's account will never really be at $8,200. It's either going to be a little bit less or a little bit more, because $8,200 occurs before an actual pay period happens. But for the sake of mathematical argument, we're going to leave it at 9.42 years. And there you go.